Okay, I'm about to show you that by using my flashing liquid process, I can produce a flammable gas from distilled water. Okay, I'm going to show you that this is just plain old water. I've taken it, this is distilled water. I took this out of that bottle right there. Now I'm going to show you. I'm going to pour it into the glass there, and I'm going to drink it. That is distilled water. Okay? And move this glass. Now the beauty part of this is an induction heater, or an induction hot plate, and what it will do is it will heat up the pan only. The surface here doesn't get hot, so you can see I can set plastic or anything right on the surface, and you can see that it won't get hot. Now what I'm going to do is turn it on, and I'll turn it to medium temperature and start. Now I'm going to turn, this is a combustible gas leak detector. I'll show you later on. I'll put a butane lighter right here, and this thing will light up like a Christmas tree. Okay, that's the detector as it blinks. Okay, that's detecting flammable gases. Okay, now we're going to check and see what kind of temperature we're starting out with. Okay, we got 116 and climbing, 121. Okay, when we get to 230, approximately 230 degrees is where I've detected flammable gas from water. Now what the trick is, you've got to get a large mass, because you've only got 60 degrees, the difference between hydrogen molecules and oxygen molecules inside of the water. And what you've got to do is reach the hydrogen without going to the oxygen. That way the hydrogen will turn to a gas, and the oxygen will remain a liquid inside of the water. Taking it above the boiling temperature of water is a secret. And to do that, you need to spray a fine mist onto a large heating element set at approximately 230 degrees, and you will detect flammable gas from water. That has got to be a molecular change. That's the only thing it can be. Watch. I'm going to show it to you right now. We're 193 and climbing. When it reaches approximately 200, there we go. We're going to take a reading right now. There you go. You see the gas. That's flammable gas, and I'm going to show you as soon as I do this a couple more times, because it's so this water influences the pan temperature, and it changes it so much that it goes out of that 200 and I'd say between 212 to 240 degrees is where you got to stay at, and you got to have a large mass to maintain that. See? Now watch. See? It's still in that zone right there. See? Watch it. You can see it's flashing like hell. That's just a liquid. That's liquid distilled water. That's all I'm spraying in there. Now, see? It's going over the temperature. See, it's not putting out the gas anymore. It's going over the temperature. Now I'm going to show you. This is the butane lighter. Now watch. I'm going to stop blinking. See? Butane lighter. Butane lighter. And all I did was squeeze this. I got to blow it away so it'll stop. But watch. See? That's the butane lighter. Now, I'm just spraying a very small amount of liquid in there, and I'm getting a gas. Now, I'm not going to get the gas smell. Now watch. I need to turn this off and get that temperature to drop back down. I'm going to see what we got. Okay, we should be right in the area right there. That is flammable gas from water. If I had a larger mass for the heat and a smaller spray, I could produce all the hydrogen inside of water, all the hydrogen in the water that I spray onto the heating element. Yeah, see, now it's going below the 200 degrees, or the 230 degrees. It's 212 to about 240 degrees is where I found that I can produce flammable gas from water. This proves that my flashing liquid process separates the molecules. No doubt.